That's how I think, kind of oddly mathematically. No. I do not know who this individual was. I just thought it was really cool. And I hope I'm not breaking any laws showing you. So, pardon me?
Did you ask him if that's really what it was for?
I did not. So either you think I'm really cool or I'm a stalker, and I hope you don't have the latter. So please take 30 seconds, think to yourself, and share with others where you see math that other people might not. Would you please finish your sentence in 5, 4, 3, 2. I thank you for coming back together after a long day of meetings and having small group conversations, large group conversations. It's really important to enhance the learning process. I apologize to any of you who were cut short in your sharing and getting to know each other, but hopefully throughout this next hour and a half, you'll have opportunities to get to know each other even better. The outcomes of this session, this 5-day continuous sequence of events, understanding the connection between visual mathematics and algebraic thinking, apply, prepare, and implement visual tasks in your classroom. We're hoping that every time we come back together, you can try something, no matter how small or how big, to come back and share and reflect and think about how do we continuously improve and make it more accessible to students. So reflecting on how students respond, exploring methods for structuring discourse, ensuring all students have a voice, and then doing some mathematics every day. Today, we're going to be looking at the concept of a variable, because believe it or not, we all have this idea of what a variable is, but it's possible we don't all see a variable the same way. And I have a card sort activity that I'm going to have you engage in at your table to see if you see variables the same way as everyone else and how they are viewed in mathematics. And then the pool border problem. Some of you may have done the pool border problem before, but we're going to have you work in groups and complete the problem and then do a share out in order to see if everybody saw the problem the same way, and connecting variables and constants to a drawing to kind of make an expression more real rather than just a bunch of symbols that we have to memorize and push around paper. And then lastly, I'm going to try to save at least 15 minutes for you to get into the Google Classroom, click into the implementation guide in order to set a, what was today's goal that Rusty said? Because we changed a little bit. A commitment of something that you'd like to accomplish over the next 4 days. And then the survey feedback form to make sure that we're getting feedback on what can we do different for the day for next session. Might any of you have questions about the purpose or the agenda before we move forward? So we have a card sort activity where you're going to receive 15 cards. They're of 5 different equations, but they all have the same structure. It's always one thing is equal to the product of 2 others. And the activity is going to ask you to sort the cards to show how the variables are used. So there are 5 cards that describe how variables are being used, and then there are 5 cards that are showing how what the variables are representing in that equation. So I know we've got some big groups and some small groups, so I'm going to ask you to kind of subdivide yourselves into 2 smaller groups if you're a really big group. So here's a set of cards. And if you're a smaller group, please feel free to stay small or join another group. And we're going to take the next 4 minutes to take the cards apart and put them in rows and columns or stacks in order to see how you see how the variables are being used and what they represent. And in 5, 4, 3, 2, and 1. So if you want to look at your final arrangement of the cards, these are the connections that we have on how we believe the cards, how the equations were being used, and what the variables were representing. And while you're making connections between the screen and your sorts, I want you to think about which equations use the variables in the way that's closest to your main connection to algebraic variables. Do you have any connections that you want to challenge the screen with? Because math is all about challenging your framework and constructing new.
Sure.
Sure. Yeah.
I will argue with the screen about just the second one being an equation.
That 40 equals 5x
It's not the
is
only
not-
equation up there.
Oh. Yes.
Trying to
And
help you out here.
thank you. We can be technical in the format that they are all equations, but when we looked at 40 equals 5x, that is representing a specific situation. The term equation came to mind as a representation of that. Would there be a better word that you would choose? Or is it just the fact that it's a little general?
Yeah.
I accept that. Did anyone, after looking at the card sort and seeing those 5 equations, think about how you generally introduce a variable to students? And do you introduce it in a very narrow framework of a variable as something that changes value? End of story?
I feel like I introduce it to them. I've never introduced to it in 5th grade or whatever. But I guess I don't really get into it a whole lot. We just start using it. You don't say, what is it again?
That's...
But I always refer to it as an unknown value.
Yes.
I use iPads and there's an app called Dragonbox.
Okay.
Has anyone heard before? Dragonbox?
My daughter plays it.
I have them play the game Dragonbox and they love it and they're so into it. And then finally I go, guess what the box is? Oh, and they're all like, oh my gosh, that's X. So it's a whole different, they think they're having fun.
What grade level do you teach?
8th grade now.
Do any of you ever find students that are in your middle school or high school classes that seem to still struggle? What is that X? Why can it be Y someday? Why is X equal to 3 today, but it was 5 on the next problem?
They don't like letters. I'm going to say I still have college students that come to me and they're like, oh, we have to do this, why are there letters? And I'm like, what is the price of the shirt you're going to buy? Do you know what shirt you're going to buy at my year that's 30% off? No. Okay, well, that's your variable then. Like, if you don't like a letter, just call it a shirt or, whatever.
You can put in a heart, put in a diamond.
Right. That's what I said. I said, okay, yeah, we'll go back to elementary. We can put a little smiley face and figure out what emojis.
So the goal was to start broad because there's so many different what Zalman Yuziskin talks about conceptions of a variable, and that they can be used to generalize patterns, to solve or simplify situations as variables to relate on a graph, or to manipulate and justify, and kind of narrow it down a little bit to the generalizing patterns and relationships is what we want to kind of focus on over the next 4.5 sessions. So it's kind of like dip our toe in the water, talk a little bit about the need to use the term variable, and then we're going to get into an activity where you're going to create your own generalized equation, and then see if everybody is viewing the same situation in the same way. Because not all your kids are going to see it in the same way, but that's the power of dialogue to get that out front. Final thoughts as we take this 10,000-foot view and start coming in to a little bit more focus. So we're going to move into the border problem. The border problem is a very classic problem that some of you, if you use Jo Boaler's work, will have seen it in her visual patterns. If you taught out of connected math, you may have seen the border problem. But before we actually start working on it, I just want to do a little bit of background about the learning intention and the success criteria that hopefully in the next half an hour we can accomplish. The learning intention to understand algebraic expressions and how they represent patterns. And you'll notice that learning intention doesn't have to end with today. Learning intentions can be generic enough to continue throughout an entire unit and not just be at the end of the 5-10 minutes of your activity or lesson. And then hopefully each group you're going to create at least one expression that can explain what each part of that expression is going to represent. So the work groups, I'm going to ask you to stand and create groups of 4 with one catch, that each group of 4 has at least one middle school teacher and one high school teacher. So the opposite of that would mean we don't want all high school teachers or all middle school teachers together. I'm going to let there be about 3 minutes of chaos while you find 3 other people that meet these criteria.
High school, if anybody needs to start.
We need a high school.
Then stay together. No, I totally understand and will honor that opportunity. So, you're welcome. So pretend that you are new.
Mike, I'm just letting you know I'm leaving early. I have to go back to school.
Okay, are you part of the group that had to leave it too? Okay.
I guess I am, unknowingly.
Oh, okay. So then you'll start with a group of 5 and then.
I'm leaving behind.
Okay.
I'll just
Thank you. May I, before you jump right in, oh, that was happy. That's okay. Thank you for, I apologize. Before you jump right in, because we're all math teachers and excited to do math as quickly as possible, I would like to make sure that we all know what we're trying to accomplish here. So it takes the form of reading the problem or having somebody else read the problem at hand, having somebody paraphrase what our goals are for the problem, and then making sure that we have clarifying questions before we just disperse and you're answering 20 questions around the classroom. So Jane's mom wants to build a square pool in her backyard surrounded by tiles as shown below. She shows you the following 3 options and would like you to find some larger options. So in your group, you're going to be asked to draw option 4 on chart paper. So I will be getting chart paper for you. And then answer how many tiles would you need for option 4, option 10, and option 100. And then the last thing as a group you're going to be asked to do is to draw a sketch and write an expression that will allow you to find the number of tiles in option N. Would somebody be brave enough to paraphrase what we are attempting to do in the next 15 minutes? Thank you very much for volunteering.
So what we're going to be doing in the next 10 to 15 minutes is on chart paper, start to draw larger objects to gain an understanding of what a 10 by so space object or 100 object look like, and then develop a generalization.
Thank you very much. You rocked it like Rusty this morning. So, does anybody have any questions you would like answered or clarified before we begin? So I will be coming by with chart paper for each group and markers, and please enjoy your opportunity to learn. Okay, if we could come together, please, in 5, 4, and we don't even have to go any further. You guys are awesome. You may notice we had a group that had to get back to school, so we lost 4 of us, but we still have a good number of groups. And I walked around the room and I looked for similarities and differences, and I asked 3 different groups if they wouldn't mind presenting their solutions. So we're going to look at the first one and try to figure out how did we find n, or what does n represent, what do the other variables represent, and then we'll see if their expression is the same or different from yours. So the
hi,
floor
I'm
is yours.
Brenda, and I was working with my partner Todd and Mikkel and Julia. Sorry, we're just getting into this now. And we had several ways of thinking about this. So, Mikkel?
Okay, I go first. I saw that it was symmetric, so I kind of cut it in half. And I noticed that there was n tiles kind of on that top, and then n plus 2 on the side, and that was doubled. So I just kind of added these 2 together. So n plus 2 plus n, and then I doubled it since it was symmetric, and then just simplified it to get to the 4n plus 4.
So then Brendan and I kind of thought about it a different way, that we saw the outside big rectangle was n plus 2, and then we saw that we could square it to find its area. But then we're missing this interior piece, which was n squared. So we represented it as n plus 2 squared minus n squared. And then we thought it would be nice to show the similarity between the two, so we solved this out to a basic linear form and solved this out to a linear form, and debated whether or not to factor out a 4. But
Now I'd like to pause before, actually I'll let you finish because you're in a groove, and then I'll pause.
Oh,
So.
mine was not very interesting. I just kind of noticed they were going up by 4s, so just a table kind of method. So I knew the slope would be 4, and then I kind of worked my way back to get the option 0, basically. So I had 4 n plus 4. We figured our kids might count, like just literally count the tiles, so that's where that came from.
So looking at their drawings, their pictures for the nth number of sides, is it visible, is it understandable where the n plus 2 in all of these drawings, what n plus 2 is representing, like where it came from? And could somebody please remind me, what does n represent?
No, it's never obvious to my kids that n is the step number. It's never obvious to my kids until we go to about 15th one. And they go, hey, n is the number of steps. Okay.
So at some point, we're hoping they're going to have that aha connection, that we're trying to create a general expression that can give you the number of tiles for a pool n number of tiles long. Does anybody have any questions for this group before we say thank you and have another group share? Thank you. I appreciate you sharing multiple methods. Wow. Rousing round of applause. Would you mind? Yeah.
I'll get up here at one point.
So the main way that we thought about it was the option down here in red, n plus 2 squared minus 10 squared. And I think where we derived it from was just kind of taking a look at the number option that we had and try and relate that to the number of tiles along the side. So we were looking for a relationship there.
Yeah, like between the outer square, that's kind of what you were doing with the outer square of the tiles and then the inner square of the water of the pool, and subtracting the water out from the tiles.
In my brain, where you did, I made like a list, or I made a recursive rule, starting from the first one. I kind of made like the top side. I had it was 3, and then on and so forth. And then the recursive rule on it. And then I eventually got to the 4 and this one.
And then we added a diving board in this one with our
because we wanted to.
Why not?
We want that big. We want her to pick her.
Yeah. The real STEM connection.
The real life application.
Yep.
Make your pool the best.
Sorry, I did not know your name.
Sorry, Bree.
Bree? You said you had a recursive. Did you write down like word for a recursive formula somewhere, or?
I kind of just wrote like I put like I've been doing with my student that is start at a number and then adding or subtracting or starting to work on that sort of equations.
And did you start with 8 or 4?
I think I did it both ways. I did like the side length first, and then I did another one for all the tiles because I got the outside tiles, I should say. So I started at 8 for that one. 8 plus 4, I believe, is what I did. I have to just look. I don't remember.
I like how you brought that up. It was an option. I didn't think.
Yeah, I did one as a side length for recursive rule, and then I did all the tiles as another one. So I had 2.
So the last group had an expression of 4n plus 4, but this group has their expression, look at the quantity of n plus 2 squared minus n squared. Well, we have the exact same picture. Is one wrong? Why do you think they may be slightly different in the way they're written, but the picture is the same?
Well, that group followed it all out and squared it out there.
It was simplified.
Squared the binomial and did all that fun stuff, and then made it more linearly.
Yeah, we stuck with this one because it gives the visual, like back to the picture, like where you can see where the n plus 2 is coming from and where you can see the n is coming from. But they do end up the same. So.
I know that personally I thought about it much more as an area problem, which is why we left the exponents there. Whereas I think if you did it in a linear, or if you took that direction that the other group did, you were thinking about it much more as the tiles increasing as linear. Right.
Additive versus multiplicative. So this is a good opportunity to start to find the similarities and differences. Because one thing kids really struggle with, and one of the Common Core standards is finding equivalent expressions. And even the term equivalent expression, we can't be much more clear that it's an expression that's equal to others. But it still doesn't really ring true to kids that when they go from one line to the next by either the distributive property or by combining like terms, that the value of that expression is not changing. You're just simplifying it, or you're writing it the way you saw it and can explain it. But then ultimately that 4n plus 4 could be considered our most simplistic way to write it. But how we get there, it's totally how the kids are seeing it. And we want to engage kids in those actions to see that they're not wrong. It's just a different perspective. So thank you for sharing. The third group, I'm going to give you the option, is your view of the picture slightly different than what was just shared?
Not that much different.
Would you mind sharing just briefly what the difference was?
So if they were looking for the border and they wanted the number of tiles on number 3, they'd ask you to sketch a drawing for it. And so if you represent it with n, each of the part that stays the same is you always have 4 corners. So you have those 4 that are in there, that's the plus 4 in the simplified version. And then you have 4 sides that are all n, which turns out to be the stage or the step or whatever you want to call it. So you have 4 n's plus 4, and that would represent whatever size you wanted it to be.
So there's our 4. And then we have 4 of our n's. And just counting, so some kids could be correct, the low floor, high ceiling, they could just start saying the expression is n plus n plus n plus n by just bringing the n's together. And then our corners. And every student in the room could start with a different starting point, but the visual, hopefully, that growing pattern allows them to start to make connections between values, the steps of that function, and then hopefully connect it with a pattern. Thoughts of what we just did, and how many of you have experienced something similar to this or given a problem similar to this for your students? Oh, I am in a much more advanced crowd. Would 1 or 2 people be willing to share how your students debriefed and how similar or different it was than our teacher debriefs today? You want to share?
I think how students debrief was different than teachers because they did not make some of the connections that I think we made. And there had to be discussion about those connections. That was the important part of my piece. But like you had said, there was accessibility to these types of problems that they got into. It was the handshake problem I've done before.
Okay. Mm-hmm. How do you prepare for those? How did you prepare for those discussions?
I think somewhat like you did, knowing what groups to call upon and have some that there was a nice connection between them.
And you could call it a cheat sheet, because I tried to figure out all the different patterns ahead of time so that I could see different groups that represented a different pattern to strategically create some dissonance to have that conversation.
I think another thing that's really important that you did that would be really important in class is you prepped us. I don't know that it was a big deal for us teachers coming up and sharing, but you asking us if that was all right, I think made my students more comfortable when I asked that.
Thank you. Is anyone else? Sure. Yes, please.
So I see 4 with this whole visualpatterns.org. It's the Vaughn Wynn and John Butler, whatever, have billions of these, hundreds of these patterns like this.
Cool.
And I, with my high school teacher, so I'm in eighth grade, would have never thought of this at all. I totally would have stuck with a linear. And I'm glad I was with the high school teachers because I've been teaching it all wrong. I thought that we could do this whole 4n plus 4, like a y equals mx plus b. I thought it would be a great way to introduce. Okay. And so this is going to be like one of our lessons that I did last year, where we had the graph and the table and the expression, how they all tie in together. But I have been allowing my students to draw a linear graph, because I thought it'd be a great way to show that linear. However, I've been letting them do continuous graph when really, whoopsies, it should have been.
Goes so far until. But it's not wrong.
You don't have half the time.
Right.
Tile. If you tile things, you should have tile in half. So I think you're fine.
Oh, thank you.
The key, I think, in your mind is staying as true to the context as possible that will grab the kids on what those mean.
So could I say y equals mx plus b? This is a...
If that is your goal, if that's your learning intention, that they will connect a linear function to the form y equals mx plus b, you nailed it.
So in that visual pattern site, I picked all the ones that were 3x plus 1 and 2x plus 1 and 2x plus 2.
And you're looking for similarities so that kids will recognize that linear patterns will always create a line.
I love this because this was tricking them into doing linear.
Graphing.
I love drawing the little...
The beauty of doing a day or a step before the connection to the linear graphs is allowing the kids to explore the patterns to see if they can come up with a way to represent it symbolically so that in the future, when they see y equals mx plus b or 5x plus 2, they might have a little bit more of a personal starting point, or at least that's the theory behind having these opportunities to explore. Yes?
Just one thing I'm thinking about, we all do standardized testing, and although all our answers were represented differently, a lot of the time maybe a student might work through a problem on the M-step or whatever and get that answer, but that response will not be on there, and they go. And then they might choose something randomly because they don't know how to work through it to make sure they're getting the correct choice.
Great scenario. This would be a starting point of the conversation, and if I had more whiteboard, we could have kept a list of all of the answers that everybody was able to visually justify as being correct. And then as we start looking at combining like terms or using the distributive property, we can start to boil this down to having 4 n's and having 4 1's, and how we can start to symbolically create equivalent expressions. And on the M step, if you're given a situation and you come up with an expression and that's not one of your answer choices, let's try another representation by either simplifying with the combining like terms or one of those extra steps. So it's really tough because there's no one lesson that will just nail it for you. It's a combination of lots of experiences. Yes?
Yeah, like she was saying, it's hard because you try to build that and your students like, your way is right, your way is right, this is all great. Everything's can be different and be right, but then you get to the test and they're like, well, you said I was right even if I didn't have one that looked like hers. Hers is on the test and mine isn't. And if your goal was to get them to solve problems,
comes down to learning intention.
Right, and then the other one is, can they simplify, using the distributive property?
Right, because our learning intention was to connect the variables and constants to the visual pattern. It wasn't necessarily to identify all equivalent expressions. which comes at a later time. Yes?
These kinds of problems are in our textbooks. We use CPM, and they have lots of tile problems kind of throughout the book with various purposes, but usually the purpose is like an entry level.
Mhm.
This is a problem that any kid can do, whether they feel like they're bad at math or not. Any kid feels comfortable figuring this out and having an answer. So I feel like this is more of an entry problem, not so much like an end game.
Mhm.
I taught this thing and now they've mastered it kind of a lesson.
Does anyone agree with
Yeah, I
her
was
perspective?
going to say,
Yeah.
I teach in a special ed classroom, and we just did the geometry, CPM, which is the carpet problem and the king. It's really early on in the geometry book, and my kids got it, and I totally underestimated them. They may not be able to make the expression, but they could tell you the n plus n, and they can work the process. And then I quizzed them on it the next day, and they remembered it with a similar problem. And it was shocking how easy it really was for them, because they need to see the patterns.
And I like to think the moral of my story or message, or the reason why we're going to be here the next couple of days, is don't underestimate the power of these 20-minute explorations, because they can really make a lot of mental connections for the kids that you can take later down the road. Especially the principles of action, the teacher actions of building, or to contextualize first, and then we can start decontextualizing in order to get into that procedural fluency and understanding. That's where we're hopefully going with, let's contextualize it, let's build patterns and feel what it's like to be a student, have conversations, what types of supports were important for the students to be able to be accessible, and then try a few things with our students and see what happens if you haven't already. And many of you already have, which is really cool. Yes?
It's kind of a weird question, but thinking of like gradual release, do you think doing this kind of an activity, because somebody said something about presenting for kids, it's easier for us because we're adults and we stand in front of people all the time. But for kids, do you think it's helpful to maybe have them do these types of things, and then as teachers, we go through and as a class look at each of them, and we can kind of direct and present and ask the questions that before we have the students go up? Or do you think it's helpful to see them struggle through presenting?
I think it's more helpful to watch students try to present it before we try to say what the students meant. But that's also where you can listen to the different conversations and connect with who really did understand what N represented and what these extra corners were, so that people aren't just raising hands randomly to come up and share, and you feel like I just wasted 5 minutes because this person just totally confused everybody else in the class. So being strategic, not only with what type of question they're sharing, but allowing that person to come up with a buddy if you know that they may not be as concise or clear with their sharing. And then as a teacher, either yourself or another student, you can have them be rusty. You can ask them to paraphrase, what did they just explain up here, for those of you that may not have made those connections. So I try to lean on the side of letting students talk first, but never feel like you can't come in and make those connections at the end for those students that might still have their wide eyes saying, what's N? Okay? Yes?
I wonder if you've ever done, I call them hosted gallery walks. It's kind of a presentation on a smaller scale. Do you know what I mean?
Yes. Please explain
For some kids, like to present in front, it can be daunting. So it'd be more like, if we're in a group of 4, I'm going to stand by the poster. Everybody else is going to kind of walk around. So I'm here at my poster, and people are kind of walking around. So I know I'm probably only presenting to like 2 or 3 people standing in front of my poster. It can take some of the anxiety off of it. So I've done those too. I wondered if that was something you would encourage.
I would absolutely encourage hosted gallery walks, smaller group sharings. Anything you do in your classroom, if you do it too often, is going to become almost too routine to the kids. So having 3 or 4 different presentation styles or ways to summarize with students I think really just helps with the energy level of teaching, because you've got 180 days to teach, and kids, it's odd, they love routine and they love to know what's coming next, but they also crave variety at the same time. So how do you add a little bit of variety without like shocking them out of the normal routine? Anyone else do gallery walks and find it successful? It also depends on your physical environment, if you can have wall space or you're not tripping over everybody's desks. So I want to hand out a middle school option in case your kids aren't yet creating expressions from growing patterns. The original border problem, if you don't mind taking one and passing around, on Joe Bowler's website, has students looking at a 10 by 10 grid, and without counting, you may. There you go. Did everybody get a copy of this? Thank you.
I need 32 more.
Absolutely. Take about 3 minutes at your table. And I want you to be able to turn to a partner and say, which of these solutions do you most connect with? Okay, so take 3 minutes, look it over, and then at your table, which solution do you most connect with?
Whereas when we teach this, we're like, oh, it's my rate. What if that's happening? So I hate it. So that they want and I don't even mention because they understand that we start with this, they understand that I love it.
I didn't even well, I did immediately.
Like you can fix it really easily.
This is the same problem, right?
It is the same structure. This is, it's just a 10 by 10. So for middle school students that you're not looking at linear expressions, that could be used to just engage them in seeing things differently.
Let them both be wrong. Projected.
And even high school students that you might think that the original problem was too far for them, this can get them thinking in parts versus just one way. I almost started with this, and I thought that would be too leading into the other border problem, so I reversed it. Right. And if everybody saw that, if we had all the different ways that we can do just those single ones, I think there would be more original thoughts without connecting it to your building it from your own exploration. So it was kind of a psychological experiment that I just did. One more minute, please. We're going to come back together. One more minute. Will you please finish your sentence in 5, 4, 3, 2, 1. You are an amazing group. There's so much energy and you're having great conversations. I want to let you keep going, but I don't want you to go home at 3:30 thinking, oh, we're running late. So what I'd like to do is just kind of spend the last 5 minutes outside of Google Classroom, the formalities of that, with some reflection that could get us a little bit more to talk about the next time we come together next month. I would like you to think of the learning criteria, which I wish I had it on the board, but I don't have a board. If you recall, and now that I'm 50, I have to do that. The learning criteria was each group creates at least one expression and can explain what each part of the expression represents. So I'm going to ask you to share, do you think you met the learning criteria of today? And then how might you facilitate one of the border problems with your students before we come back together if you haven't already done the border problem? So think about planning, think about which border problem you might want to try and how you might slide this into your curriculum map that may already be planned out for you. So we're going to take 5 minutes, talk at your tables. Did you meet the learning criteria? And how might you facilitate the border problem?
I think that the whole one about it, I don't like it.
I think you did that square and you did change what's the area. Because if you did area of the border, then it works then to subtract. You know, the big square subtract that. But again, your question.
You could.
That's what we were saying.
About to introduce your quadratic.
If you change, tweak the question a little bit.
You can't do that. That's not allowed. To actually. So operations always drive by context. Tweak what you're asking.
Or and math.
I think she said .org, but I'm not sure if I wrote it down correctly. Actually, I'll do a quick search.
But then being able to they wouldn't be able
Maybe the top vertical with the green, purple, and red. Can I? And we'll look.
Some of our other kids, just because they like to plug and chug, we do different. But they might write it out this way, where representing the side, they start putting the seats and have stuff, and they start seeing, well, if I took away one from that three, that would make it 10. So then if I did the x minus 1, and multiply by 4, and then that's it's crazy. It's hard to
One more minute, please. One more minute.
Which is weird because
I'm sorry? Did I borrow it?
You guys took it back up to make that. I think it's on you.
Oh, yes, I did. Thank you for having a great memory. They're doing great. There's a lot of energy, and it's really hard to stop them.
That's perfect. That's exactly like, sorry about the...
That's okay. They adapted. This is education, just like school.
I went over there and I was like, your video is opening the other room too right now, so we're going to try to sort that out, but...
They were very flexible.
Sorry.
That's okay.
what happens, right?
It is.
Implementation guide is working in other rooms.
Is it?
Should
Cool.
work for you.
That was our next slide.
Yeah, and then the bit.ly on the last slide should work.
For okay. Yep. That's where we're going right now.
I'll maybe check it in 10 minutes.
Okay. We'll be wrapping up. Okay, could we please come back together? Thank you. Could I get maybe 2 people to share what they are planning to do between now and the next time? How you maybe using this with one of these problems with your class? Yes.
One thing we had thought about was remembering visual patterns exist and using them in our class.
And because you mentioned that, and I forget which one of you ladies mentioned the visualpatterns.org, or is it .com or?
.org.
It is .org? Okay. So visualpatterns.org is a resource where Jason and I are hoping to bring additional resources. We didn't want to come in with our guns a-blazing with lots of stuff to look at, but if you're looking for other visual patterns beyond the border problem, that'll be a place to go. Yes, sir.
Just another thought on how we can connect this in the classroom. I work with students who have struggled in the past. It's a Algebra 1 Essentials class, so that, it's a different track than the regular Algebra 1. And just talking about how I would have to scaffold this a little different. I think the kids would struggle taking it from the concrete to the abstract. So just how having them create tables or create those visuals, those drawings of how it's growing, and then transferring those into tables, and then just using questioning techniques to get them to take it from that concrete to abstract.
Thank you. So if you have students that you believe that scaffolding would be necessary, absolutely provide those rungs to the ladder. We always want to try to take a scaffold out every time we're doing something, but sometimes doing something whole class with the brainstorming process, if you're uncomfortable letting 7 groups of 4 go wild in your classroom for the first time, maybe doing some modeling, having individuals share what they're seeing. So, excellent. We're hoping that throughout the next 4 days, we can have more conversations about how are you making it work in your classroom, and how are your students responding. So it's 1:45, which is when I wanted to transition to Google Classroom, because I promised Rusty I would. So those of you that have computers, we would really appreciate if you went into your Google Classroom. And this is where I'm hoping the buddy system can help people find this class.
Yours does too.
Yeah.
I'm doing the same thing. It says requested. That's when you post it.
I posted the PowerPoint, so I will need to change the parameters tomorrow morning.
Sorry, I requested access.
No, that's okay. I didn't realize that I didn't allow it to be viewable with everybody who clicked on it. I'm new to Google Classroom myself. So on Google Classroom, if you could pull up your implementation guide and just 30 seconds or less, type in a commitment that you want to consider moving towards. A few of you already shared with the class some of your thoughts. But we find when you put goals in writing, we're more likely to move in that direction. The implementation guide, I believe. I think you're gonna.
Because somehow my name came up on this.
Yes,
So
it's your individual for you. Your name comes up on it.
It's individual to you.
So that what he's doing is you're sharing it with him, and if you don't have your name on it, he doesn't know whose it is.
So is your name?
I figured that one out.
Okay.
Yeah.
So you don't have to make a copy of it.
Yeah, that's what I was thinking, but it's already done. So is that part of the new Google Classroom? Is that
It's how he sets it up.
Rusty set it up for me. I apologize that I don't know the magic behind the
You can set
scenes.
it up as a, like when you make an assignment.
Going across where it'll be the, I think it's
Yes, I shared the PowerPoint, but I realized that I did not give you. Yes, that survey is going to be.
I'm almost out of battery.
Okay.
I just wanted
Oh.
to read what you wanted us to do.
Sorry.
You're just filling up the.
I'm asking you to just fill out the commitment line of the implementation guide. That is a starting point. It's not set in stone. It's yes, absolutely.
How big of a commitment is this? Is this like, hey, I'm going to try this square activity between?
You can shoot. You can shoot for the moon right now, and then modify trajectory a little bit when you realize life takes over. Yeah.
Backdate it, whatever you like. In the computer? In the computer. You could backdate it, say, I know.
The commitment, which I'm colorblind, so I'm not sure what colors those are, but the third frame down.
Yes, you're posting the whole thing every
Did you say you had that on? Patient. Mine almost out of battery.
Yes, I was just going to type the code for the reflection, which I think all of you have it in your handouts, but I'm putting it up here for 6IR, IV, 8F,
That's what I put in, so I thought it was
and that is the evaluation for today, the reflection piece, or what they're calling progress monitoring.
I thought that was my code to get in my
Is it? Oh, it's. Oh,
It's on the previous slide.
I'm sorry.
The previous reflection.
There we go, the bit.ly. That's. I knew it was in my PowerPoint. I just. We are hoping before we leave today, you can go into the bit.ly and provide feedback for, and if you can't do it before we leave today, if you're willing to do it on your time this evening or before the end of the week, that would be wonderful.
I think you answered this already. You said that we should turn it in? Or
I think right now you can leave it as just an open document.
What they had us do last year was they had us turn it in, and then we had to unturn it in every week.
Okay.
Or every meeting. Because you can unturn it in. I can't remember what it's called.
Unsubmit. And then you can make changes again. So if it's turned in, you can't edit it until you unsubmit it.
But they can't see it until it's
I'm going to turn it in.
do
Rusty will
something.
send emails sometimes.
Yeah.
I never. They never.
Well, if you never did it, then you didn't follow up.
Well, because I joined late.
They probably thought you never did.
Well, I joined late because my district signed up for me, and I don't think they ever had me do it. I didn't even know it existed. Nor can I figure out what
That
it
website's
is.
too sensitive. I didn't think that was a thing.
The bit.ly?
Bitly, it's just for Bitly's.
Yeah, I think.
Because otherwise it's so many Bitly's. There's only so many, there's bazillions of Bitly's. Right, that's why I say it's too much.
It's different than
Hubert, holy cow.
That's my favorite game. Man, I love
Well, as people need to get going, I just want to say thank you for coming this afternoon and I hope you had a great day from the beginning until now. And I look forward to exploring visual patterns with you and Jason for 4 more afternoons. So have a wonderful afternoon. Thanks for participating.